All right, so today we are going to work on and review some of those fundamental concepts that you need in order to do trig, in order to do a trig effectively. So those of you that were in geometry last year, which should pretty much be all of you, you've done trig in geometry. That's sine, cosine, tangent. You did the rough basics of trig. Of course, we'll go more and more in depth with Algebra 2 trig, but the same things apply. So today, / a little bit of tomorrow, we're going to go through some of those basic concepts that you need going into trig. And one of those first concepts that you need is the idea of how to round. So you need to know how to round. So rounding is essentially knowing place value, knowing how to round. So when you round, remember it's 5 and up, you round up. 4 and down means you leave it alone. So the two primary rules for rounding. There's 3 examples that we're going to look at. Definitely ask questions if you have questions. Otherwise, I get to assume that you know what you're doing. So example A. Round 7.2835 to the nearest hundredth. So hundredth is 2 numbers behind the decimal. Hundredth is 2 numbers behind the decimal. So 2 numbers behind the decimal is the 8. So you look at the number behind it. The number behind it shows you what you need to do. So that 3 is 4 and below. 4 and down means you leave it alone. So this 8 doesn't change. So your rounded answer is 7.28. Underline the number that you're rounding to, and you look at the number behind it. That will dictate how you round. Any questions, part A? All right, part B. Round 21.1819 to the nearest tenth. So tenth is 1 number behind the decimal. Tenth is 1 number behind the decimal. So 1 number behind the decimal is 1. So you got an 8 sitting behind it. So 8 is in the 5 and up category. So you round up. So that 1 becomes a 2. 21.2. All the other numbers after that falls off. All the other numbers fall off. Then example C. 9.3549 to the nearest whole number. So the whole number is the first number in front of the decimal. First number in front of the decimal. That's that 9. So 9, the number behind it is a 3. 3 is not going to change anything. And 9. Once you round it, all the other numbers fall off. So, questions on rounding? Questions on rounding? If you have questions, make sure you ask. If you're just laying in bed trying to sleep another 20 minutes, that's not a good look for you. Ultimately, you're responsible for the content. So, part B. The next basic skill, ratios and proportions. Next basic skill of ratios and proportions. So, ratios are set up as fractions. And we always reduce the fraction after we write it. Ratios are set up as fractions. So, example A. Ratio of BC to AC. So when you set up the ratio, you set it up in the order that they gave it to you. It's not negotiable. You must set it up in the order they gave it to you. So BC, B to C was 8. AC, A to C, 6. That's 8 over 6, which you can reduce to 4 over 3. That's it. That's the end of the problem. Any questions before we continue? The other ones work pretty much the exact same way. So example B, BC to AB. So again, BC is 8, A to B is 10. Over 10. So 8 over 10 reduces to what? You can't leave it as 8 over 10. Actually, it's marked wrong. So what does 8 over 10 reduce to? So 8 over 10, if you reduce it, 8 divided by 2 is 4. 10 divided by 2 is 5. 4/5. Again, you must reduce the answer. Notice that I'm setting it up and then I'm solving it out. Don't just put the answer. That's a 100% way to get it marked wrong. If you can do it in your head, you can also show the work too. AC over AB. AC is 6, AB is 10. 6 over 10. Three-fifths. For these notes, yes, you can pick them up. I mean, you still need to write them for now. But yes, you can pick them up. Again, same rules apply, ladies and gentlemen. If you want a print copy of the notes, you can come up and get them. They'll be in the south cafeteria. All you gotta do is ask the security guard. Yeah, I'm paying attention to see who's taking the initiative about their work. Because too many of you all I'm fearing are going to be on the borderline. I can tell you right now, do not wait until it gets closer to the end of the school year to then want to start putting in the initiative. Because I'll be the main one that's petty and say and tell you, no, you're going to retake this class. You're not going to wait till the last minute to then want to do some work. No, you do it again. Those are ratios. Proportions is when two ratios are set equal to each other. So to solve a proportion, cross multiply, and then solve the equation. So we got two examples to work with there. Solve the proportion x over 14 equals 0.7568 over 1. So cross multiply is just like making an x. X gets multiplied times 1. And 14 gets multiplied times 0.7568. Cross multiply. X times 1 is simply x. 14 times 0.7568. We got a calculator we can use for that. 10.5952. That's your answer. So Mahalia, in this case, since they didn't tell us where to round, we can leave the answer like this, but they would have to tell us where to round in order for us to either round up or down. I see where you would round up. If they said round to the nearest 10th, then you would be rounding up. If they said round to the nearest 100th, you'd be rounding up. So I see where you're coming from with it. Since directions didn't tell you, then you don't need to worry about rounding. So hopefully that answers your question. So let's do one more example. Part B, solve a proportion. Same rules apply. Cross multiplying, just like making an x. So 6 times 21 equals 9 times y. Let the calculator do a little work. 126 equals 9y. Divide by 9. So 14 equals y. So 14 is equal to y. Any questions with proportions? Writing a ratio or solving a proportion? Writing a ratio or solving a proportion? Here in your seeing, so we can move on to part C. Yeah, like I said, closed mouths don't get fed. So if you know you have a question, you don't say anything, then I get to assume that you know what you're doing. All right, part C. Triangle sum property. So the sum of the angles in a triangle must always add up to 180 degrees. Standard principle. Standard principle. All three angles in a triangle have to add up to 180. Now, since we're dealing with right triangle trig, one of your angles is going to have the box on it. So that indicates a 90-degree angle. So one of your angles is 90. Solving is pretty simple. So example A, we know that we have a 90-degree angle and a 37-degree angle. So add the two angles up. And then subtract from 180. That's it, problem's over. There's three angles in a triangle. One of them is 90, one of them was given. Add them up, subtract from 180. Boom, there you go. Part B is the same way. There's your 90. Could be 68. 90 and 68 is 158. 180 minus 158. 22 degrees. Then example C. Again, there's your 90. And you're given 28. And 28 is 118. 180 minus 118. 62 degrees. So that's how you work through finding a missing angle. So again, there's a reason why these are listed as basic skills. So they're basic concepts that go with trig. Any questions, parts A, B, or C before we move on? All right, so let's look at part D. So part D is pretty much where we're gonna stop. So let's start with part D. Simplifying square roots. So simplifying square roots, we did this earlier in this class, and for your case in first semester as well. Simplifying square roots. That means you find two numbers that multiply to the number under the square root. One of them must be a perfect square. So, you don't remember what the perfect squares are? So, as far as perfect squares go, one is a perfect square, because 1 to the second power is 1. 4 is a perfect square, that's a 2 squared. 9 is 3 squared. 16 is 4 squared. 25, 5 squared. 36, 6 squared. The other ones that are members of the first 12, you have 49, 64, 81, 100, 121, 144. So that's the first 12. At minimum, you should know the first 12. So when we break down square roots, the only one that we don't use 1, because 1 divides into everything. We don't use the number 1. So in the case of 12, we need 2 numbers that multiply to 12. And one of them has to be on this list. One of them has to be one of them. So 12 multiplies to 1 times 3. Once you figure out what the 2 numbers are, then you take the square root. Figure out what they are first, take the square root. Square root of 4 is 2. 3 you can't break down anymore. That's your final answer. So breaking down square roots, you have to know your perfect squares. So 45, same thing applies. 45 is not a perfect square. Otherwise, it would be on the list. So we got to break up 45. So if you have a hard time figuring out what numbers to use, take the number underneath the square root, divide it by the first number on the list. If it works out evenly, then you can use it. 45 divided by 4 is 11.25. Womp, womp, womp. Can't use it. Go on to the next one. 45 divided by 9 is 5. So you can use those. 9 times 5. Again, breaking down square roots basically depends on how well you know how to multiply and divide. Square root of 9 is 3. Square root of 5. Say it's the square root of 5. Any questions, parts A or B? Okay, let's go ahead and wrap this up one up. So, 63, same rules apply. Find find 2 numbers that work. So 63 divided by 4, that's a decimal, so that's not going to work. 63 divided by 9 is 7, so we can use those. Square root of 9 is 3. Square root of 7 can't be broken down anymore. Again, there are certain numbers that won't break down anymore. I'll write those out in a second. So part D. So you have the square root of 80. 80 is not on our list. So we get to get it. So 80 divided by 4 is 20. So technically you can use 4, you can take the square root of 80 and use 4 times 20. So you can do that. The square root of 4 is 2, but 20 can still be broken down. 20 divided by 4 is 5. That means you would have to keep going. Two times 2 is 4. That's 4 square root of 5. Which that is the answer to the problem. But notice you had to break it down twice. You could have solved this problem by only breaking it down once. 80 divided by 16 is 5. Square root of 16 is 4. 1 step. 1 step. Now, does it matter which way you do it? No. If you want to do it using 2 steps because it makes sense to you, do it that way. Just make sure you show your work. If you can do it in 1 step, it'd be great. Do it in 1 step. Just show the work. Either one of those would be okay as a final answer. Any questions on part B? All right. So as I mentioned, there were some numbers that don't break down anymore. So some of the numbers that don't break down. Would be square root of 2, doesn't break down, square root of 3, square root of 5, square root of 6, square root of 7, square root of 10. So those are the first 6 that wouldn't break down. So if you get any of these 6, then you're done. Notice a few of them showed up in our problems. And those numbers don't break down. So that at least takes us through part D. Tomorrow we will rationalize, review the Pythagorean theorem, and then we will start with trig. We'll start off with trig. This